Okay, good afternoon, everyone. Today's class actually follows directly on from yesterday's class. Today we're going to be discussing forensic toxicology. Basically, toxicology is the study of drugs in the body fluids, and it's the responsibility of a toxicologist to actually do three things. The one, hang on, why am I not on here? Let me see, there I am. So the first thing is toxicologists examine and try to identify a particular drug, establish the identity of a drug, establish the concentration of drugs, and then also assess the impact of that drug. And a forensic toxicologist may be called on to testify in court to all three of those things. Forensic toxicologists very often will examine not only body fluids, blood, cerebrospinal fluid, that sort of thing, but also the concentration of drugs in the various tissues as well. And very often forensic toxicologists are not only involved with crime, but may also be involved with hospital poison units and this sort of thing in order to assist in identification of intoxicants of one sort or another. Forensic toxicologists, a toxicologist is faced with an enormous difficulty. And the prime difficulty is that there are so many thousands of different substances which human beings can in fact take into their bodies in one form or another. It is true that the range of drugs which a toxicologist deals with under normal circumstances is relatively limited, and the drugs are often very, very well characterized. So alcohol, we're going to talk extensively about alcohol today. Things like cocaine, barbiturates, tranquilizers, all of these sorts of things are very well characterized and relatively easily identified. The problem for a toxicologist is very often they are presented with a situation where they have no clue as to the identity of the drug, and they need to screen through thousands of different drugs in order to establish an identity. Toxicologists very often depend very heavily on information from investigating officers and witnesses, desperately trying to get any clue they can as to what a drug might have been that somebody has had ingested, which they are having difficulty identifying. We're going to spend most of our time talking today about alcohol, because alcohol is the most commonly used and the most commonly abused drug in Western society. This does not apply in many societies where alcohol is banned or where its use is prohibited by religious practice. But certainly in Western societies, alcohol is very frequently used, and it's to such an extent that an entire branch of forensic toxicology is devoted to the measurement of the amount of alcohol in the body in those matters which pertain to the law. And alcohol is very, very frequently an ancillary to all sorts of other events. For example, in the United States, more than 17,000 deaths a year occur on the roads and are directly attributable to alcohol intoxication. That is actually a staggering figure. It is much lower, however, than it has been in previous years. And that is because of the institution of very stringent controls. Although it has to be said, the United States legal driving limits for alcohol are somewhat more liberal than they are in many European countries, for example. So we still allow people to drive who have actually been drinking and they remain legal as long as their blood alcohol concentration is below a certain level, which is 0.08. So that is the federal limit. So alcohol is a depressant. Remember what we said yesterday about the depressants. The depressants exert their primary effect on the central nervous system, and they literally do exactly that. They depress cerebral functions. And here comes alcohol's tender trap, because what alcohol does is it depresses feelings of shyness, of anxiety, all of those. It often makes us feel happy, and relaxed, and socially interactive. And those are all actually reflections of its depressant nature. It's just that it's depressing things, and we end up feeling better because those functions have been depressed. But at the same time, it depresses things like inhibition, and it depresses control over emotion. So people who are drinking very often become emotionally labile. They begin to overreact, and they're prone quick to anger or to become maudlin. This is the typical picture of the maudlin drunk weeping into their beer. Because the control over emotion, rational control over emotion, begins to be lost. It is depressed by the action of the drug, of alcohol. Now, in toxicology, it has been established that there is a direct relationship between blood alcohol concentration and the concentration of alcohol in the other organs, and especially in the brain. So blood alcohol concentration is measured as a proxy, and it's a proxy for the amount of alcohol that is actually exerting its effect on the rest of the body. So for toxicologists, the establishment of a blood alcohol concentration is tremendously important. In the case of a post-mortem, where a death has occurred, very frequently, no matter what the circumstances, they will test for blood alcohol concentration, but they will also test the presence of alcohol in the other organs of the body. And I've mentioned this before. They may take samples of various organs and body fluids in order to establish the alcohol concentration. So, for example, they may take samples of the blood, cerebrospinal fluid, but also things like the vitreous humor from the eye, which accumulates alcohol relatively slowly, but loses it relatively slowly. It's a good where alcohol concentrations may vary elsewhere in the body as time passes. They remain relatively stable in the eye, so it's a good source of information at post-mortem. In a living person, obviously, the primary source of information is going to be the blood itself, usually, or the breath. We'll talk about that in a minute. So you'll hear talk of alcohol being discussed in terms of units. And a unit of alcohol is 10 milliliters of pure alcohol, or 8 grams of pure alcohol. That is 1 unit. And this has a special meaning because this is the amount of alcohol that a healthy adult will process completely in about 1 hour. So 1 unit, 1 hour, 1 unit, 8 grams of pure alcohol. The amount of alcohol in various drinks varies quite a lot. It's kind of interesting. Have a look here. You'll see that in actual fact, for a drink, it's usually between 1 and 3 units in a drink. Beer here, lager rather, which is a higher alcohol, is 2.3 units. A bitter, which is even higher, is 2.8 units. A glass of wine is 2.3 units. see they're all quite close to one another. So and whether you're drinking a glass of beer or you're drinking a glass of wine, you're drinking about the same amount of alcohol, no matter what you might think. It's just the volume is different. And a beer may take you longer to drink, and also will take you longer to absorb the alcohol in actual fact. Short drinks like shots, as you can see here, if I move this out the way, surprisingly have only about one unit in them. But they're called shorts for a reason, and that is that they're very quickly drunk. And what you'll find with people who regularly drink is they have a certain level that they will drink to. So without even knowing, of course, what their blood alcohol concentration is, we instinctively monitor the effect that we want to get from alcohol and drink to that effect. So in social drinking, that may be fine and easily controllable. But as with all use of all drugs, there is a tendency to develop a tolerance and to need a higher and higher dose to achieve the same kind of psychological and physiological effect. This is one of the drivers that moves people to drinking more and more heavily. They're drinking to effect. And they are in actuality developing tolerance to the alcohol at the same time. Now, the blood alcohol concentration is, if you drink just one drink, and let's just, for the moment, we're just going to say you're going to drink it on an empty stomach, because this makes a difference. You don't drink one, it's going to push your blood alcohol level, depending on the drink, the size of the drink, and how quickly you drink it, anywhere from 0.01 to 0.05. And this is typical, the first drink, and it induces this feeling of relaxation and a benign sense of well-being, some loss of inhibition. But at the same time, even at that level, even one drink has perceptible effects on higher neurological function. And even one drink will begin to impair, for example, will begin to impair your reflexes. It will also impair the speed at which you analyze situation. So even one drink can induce sufficient deficits into your function, for example, that you should think very carefully about driving or doing anything like that, even if you think you've only had one drink and it can't have done much to you. 2 to 3 drinks, which is this is the kind of social level, right? When you're out drinking with your buddies and over a couple of hours or whatever, you drink 2 to 3 drinks. That pushes your blood alcohol concentration to 0.06 to 0.1. Now, this is high. This is high in terms of what a legal limit is for driving, which is 0.08. This is the stage where people may perceive quite clearly that they are in fact tipsy or drunk. They themselves may well be aware of the fact that their psychological and physical functioning has been affected by alcohol. And at the lower level, still pleasure is pleasurable, a pleasurable sense of inhibitions, depression of inhibitions. This is where people feel like they're telling great stories and they're the life and soul of the party, etc., etc. At the higher levels here, up 0.1, this is where people, especially if they're not used to drinking, this is where they might begin to feel a bit nauseous, but sleepy. And in addition, they may begin to lose control of emotional control. So may at this stage be quick to anger or quick to burst into tears or feel, emotional, etc. In addition, at these levels here, if you were to be examined by a peace officer for alcohol usage, they would very quickly be able to pick up that you had been drinking from a range of physical effects. In particular, that your ability to track with your eyes begins to be affected. Of tracking with if you just look at your figure and just move it one side to the other like that, that's actually a very complex neurological process. You're coordinating both eyes to move and follow something. People who are inebriated, especially as they move their eyes to one side, their eyes begin to flicker like this. The eyeballs actually move. It's called nystagmus, and it's one of the ways in which a police officer will begin to assess you for intoxication, or they'll get you to perform this tracking. 3 to 6 drinks, this is serious inebriation. A blood alcohol level of 0.11, 0.2, this is really serious inebriation. And it's in this range that we begin to worry about people's reactions to situations and to other people. Which is in this range that rage, alcohol-driven rage, and this sort of thing begins to really become a risk. That people begin to show extremes of emotion, not just the ordinary emotional lability that we have here, but now real extremes of emotion. Rage for virtually no reason, for example, violence, tripping over from verbal to physical violence very, very quickly. This proceeds, people can carry on can drink an enormous amount at one sitting, 6 to 9 drinks up to 0.3. And this, we're now actually moving to a dangerous place, because we're now, in many people at this level, will begin to see actual physiological depression of physiological function. And you're beginning now to see pronounced impairment of movement. People can't keep their balance. They start falling. They can't speak. They can't keep their thoughts ordered. And all the way through here, this higher level here, even at 0.1, but especially this here from 0.11 on all the way through here, there may be impaired ability to form memory. And it's in these regions here that people begin to suffer from alcoholic blackout. And they actually are unable to remember anything about what has happened, because their ability to form short-term, long-term memory is suppressed. They're existing purely in the moment. People die of alcohol poisoning, and it's in this range here from 0.31 to 0.4 that this becomes a real possibility. If you are out drinking with friends and you see somebody in your group or somewhere else who has passed out from using alcohol, you should regard this as a life-threatening situation, the same as you would regard any other drug overdosing. This can result in coma and brain death, and is not a laughing matter. People think this is funny when people pass out. It's not funny at all. It's in fact a sign that their neurological function has been so badly affected that they're at risk of actually dying of alcohol poisoning. At even higher than that, people can very quickly lose brain function, stop breathing, and have heart stoppage. So all the way from here, all the way through. It's a continuum, obviously. But what we're watching as people drink is the depressant effect of the alcohol all the way through. So when we drink something, first of all, we absorb it. That's the first step. Second, once you absorb alcohol, by the way, is very rapidly absorbed through the stomach wall and through the wall of the small intestine. It's extremely rapidly absorbed, especially if you're drinking on an empty stomach. Once it passes straight into the bloodstream and is circulated, and it exerts its various effects, and it is then eliminated. The body immediately begins processing it. We just in normal course of evolution and of the way we live and everything, we are continually exposed to alcohols, various alcohols, and ethyl alcohol, ethanol in particular. Even ripe fruits, these other things have a small amount of alcohol in them, even though you don't think it. But the body needs to process that. So we have natural enzymes which will process, and these are largely in the liver. Kidney, to a certain extent, does also eliminates, but largely alcohol is processed by the liver. So I've said once or twice that it makes a difference whether you are drinking on an empty or on a full stomach. And the difference it makes is in the amount of length of time it takes you to absorb the units of alcohol that you've ingested. If you drink on an empty or even with just a small amount of food in it, you will very rapidly absorb all the alcohol, and you will absorb usually 30 to 90 minutes, depending on what you're drinking, how quickly you're drinking, of course. 30 to 90 minutes, you will absorb all of the available alcohol into your bloodstream. But on a full stomach, that becomes extended. It be to 2 to 4 hours. So it sounds like a very good idea that you don't drink on an empty stomach, that you should eat first if you're going to drink alcohol at all. There is a problem with this, though, and that is what I said earlier. Very often we drink to effect. So if somebody has a full stomach and they have a drink, they are going to absorb the alcohol slowly, and they're not going to feel the desired effect from the alcohol. And they are tempted then to have another drink in order to boost, it certainly will, you'll boost the amount of alcohol that you have in your stomach. You will start to absorb more. But can you see that it's a trap? Because it's a good idea to have a full stomach and drink, but be very aware, people should be aware of the fact that it is going to take longer, that they should delay the next drink, not immediately start drinking more to try and increase the rapidity with which they feel what they regard as being the beneficial effect of the alcohol. People with full stomachs, unfortunately, often end up drinking more than people with the empty. Person with the empty stomach is very quickly aware. Oh no, I must hold off. I mustn't have any more. Person with a full stomach thinks I can carry on drinking, or I should carry on drinking more, and all of a sudden it all catches up to them. So here's an actual depiction of what is happening. This is an experimental situation, and they're actually measuring the blood alcohol, and this is milligrams per 100 mil, or percentage weight for volume, and that is what we're referring to when we say the blood alcohol concentration. So it's the number of milligrams per mil, or the percentage of circulating alcohol of 0.08 is our legal limit for driving. At or above that, you are breaking the law. Below it, you may receive a warning from the police officer who tests you to tell you need to be very careful because you will be impaired, but below 0.08 is still legal in the United States.
Overseas, it's much, much lower. 0.02, I think, in Sweden, 0.04 or something, I think, in continental Europe. I can't remember. But the levels are very, very much lower in other countries. In fact, you should not drink at all if in those countries. People just don't drink and get into their cars. The penalties are also very severe in other countries. People lose their licenses for life for a single episode, where here we are more lenient. So here's the experiment. What they've done, they've filled somebody full of potatoes, a good starchy meal, and they fed them the same amount of alcohol. They fed them 5 ounces of 80% of 80 proof. That is 40% alcohol. Proof is a measure in the liquor trade, and 100% proof is 50% alcohol. So 80 proof is 40% alcohol, and that's standard for things like whiskey, those sort of things. So they're giving them 5 ounces of whiskey. It's I think about a double shot. And they've then gone and measured the blood alcohol concentration. Here it's time, and you can see here within an hour and a half, within 90 minutes, on the empty stomach, they've got a very high. It's 0.09, 0.1. There's 0.09, sorry. There's 0.1, so it's about 0.11 blood alcohol, way over legal driving limit within 90 minutes. Person with a full stomach, the same amount of alcohol, but it's absorbed much more slowly. They'll carry on absorbing for a long time, but they never reach the high level. Here they're at 0.04, well below, well below the legal driving limit. But remember what I told you, if this was just a life situation, this person's out drinking and they're drinking to effect. They're not feeling the effects here. They may be tempted to have another drink or another and another to try and get the effects, and very soon they will push their blood alcohol concentration way up, and it will last for a very long time. This slope here, the downward slope here, represents the elimination stage. The body very rapidly begins processing alcohol in circulation. And it is processed largely by the liver and a little bit by the kidneys as well. And because of this, it is so widely distributed. When this is the reason why, in an autopsy case, the toxicologist or pathologist will take samples from a wide range of tissues and body fluids for testing by a toxicologist to determine the actual concentration in the various tissues. That not only tells the investigator the limits, how much alcohol was present, it may also give a timeline for the alcohol consumption and be able to tell how long before death was alcohol consumed. Okay, so the processing system, largely in the liver, is by a set of enzymes called the alcohol dehydrogenases, and they process alcohol into metabolic byproducts, and at the same time, we actually begin to excrete alcohol in various ways. The most important, forensically, the most important is in the breath, but we will also excrete in sweat and in the urine. The importance of it being excreted in the breath is, as I said before, there is a direct correlation between the amount of blood alcohol concentration in the blood alcohol,
concentration of alcohol in the brain, but there is a direct relationship also to the amount which is excreted in the breath. And we can actually measure, if we can measure the amount of alcohol in the breath, we can get a proxy measure of what it is in the rest of the body. So that is the importance of the breath test. One thing I should mention, if you, it's very easy to overload the liver. And one of the things that happens when this happens is that the liver, these alcohol dehydrogenases work inefficiently if they're overloaded, and they produce metabolic byproducts, which are actually toxic. There are two of real importance. The one of a set of chemicals called the aldehydes, and I don't know if you've ever encountered anybody the morning after, the day after they've been on a real heavy drinking bout, and they have a very distinctive smell to the breath. And that is imparted by these aldehydes, and aldehydes are toxic, and they are a major cause of the feeling of hangover, people feeling ill after they've had a heavy drinking episode. Could you just give me 1 second? Just excuse me for 1 second. That bonging noise is because I left my office on. Can everybody see me and see this?
Yeah.
Okay. So if you don't forget that your body is processing at a pretty much a set rate. If we go back to this graph here, you'll see there's pretty much a straight line. And the rate at which you process is about 0.015% per hour. So if your blood alcohol concentration was 0.1, which you'll remember is like 3-4 drinks, not that much for an evening of drinking, takes about 6.5 hours for you to come down to 0. And depending on how fast you drank that, etc., you may well overload your liver, overload the physiological elimination ability, and start to produce these kind of byproducts. In addition, very often in alcohol, in drinks, there are other alcohols present in small amounts, especially methanol, and these also are toxic. And although they are present in very low amounts, if you drunk a lot, these contribute to this feeling of hangover. And hangover is classically has headache, often the nausea as well, muscle aches, joint ache. It can actually feel almost like flu. And that is because of these coming into circulation. Those aldehydes, by the way, are quite difficult to get rid of. It takes quite a long time for your body to process them and eliminate them. So for a toxicologist or for a police officer or anybody dealing with the effects of alcohol in a human being, there are various ways in which we can legally determine blood alcohol concentration. And the first, of course, is by taking a blood sample and determining the amount of alcohol in the blood. But it is, in most jurisdictions, it is legal to also measure the alcohol content in the breath and use that as a proxy. Now, but under special circumstances, which I'll explain to you. The rationale is that the amount of alcohol you expressed in the breath is directly related to the amount of alcohol in circulation in the blood. So our legal limit is 0.08%, 0.08 grams of alcohol per 100 milliliters of blood. And above that, you are immediately arrested and taken off the road. So there are two ways in which this can be done. we're all used, of course, and you may, if you're a driver, you may have been through one of these field tests of sobriety, which officers are authorized to do. They are authorized to stop anybody on the road and examine them for evidence of inebriation. This is a somewhat special circumstance constitutionally, but it is one which has been agreed on by all the states because it represents, it is an attempt to avoid such a catastrophically dangerous situation. And that is that people can actually drive when they are incredibly drunk and look perfectly normal, but be in very, very, very dangerous on the road because all of their judgment, their reflexes, everything is impaired. They may be driving straight, but that's about all that they can do very often. So officers are authorized to stop people, and you know that sometimes they will set up checkpoints where they'll check everybody going through in an attempt to weed out people who are driving drunk. Field sobriety tests, there are two things which they will do. The first is that they may ask the driver to take what we call, by common parlance, a breathalyzer test. So that is this is the typical one. Nowadays, you seldom see the thing of inflating the bag anymore. They're mostly digital, and it's portable, easily used, handheld, and they will very quickly establish a blood alcohol level in relation to that 0.08 limit. Anything approaching that, the officer, anything at 0.08 or over, the officer will immediately take the person into custody and remove them from the vehicle. However, this, whatever they see on the field tester, is not admissible in court. Instead, a laboratory grade result has to be produced as proof of intoxication. And that is done, I'll show you in a minute, that is done under special settings. The officers are also authorized to conduct a field sobriety test, which tests reflexes, balance, coordination, all of which are severely affected by alcohol. I told you about this, the eye flicker. That is called the nystagmus test, and is characteristic of inebriation, especially as you approach that 0.08 limit. They will also be asked to do all these things, to walk, turn on one foot, turn around, come back, walk a straight line, walk heel to toe like this, and also do finger tests to the nose. All of these things are tests of coordination and of balance, and will very quickly show if somebody is inebriated, and you can be failed for failing these physical tests, even without a breathalyzer test. I just put this in, by the way. This is just for your amusement. You can watch this just for amusement's sake, but it's not a. I know it's not a laughing matter, but in any case. So failed field sobriety test immediately results in arrest, and you're being taken to a precinct. But that failed field sobriety test is not evidentiary in nature. And in order to take that to court under charge, the blood alcohol concentration has to be determined in a scientific manner. And the first way in which it can be done is by using a highly sophisticated version of the breathalyzer, which is an infrared testing device, which gives a blood alcohol concentration, and it gives an error. And that is acceptable in court. It gives the error range. It says blood alcohol concentration such 0.09 plus minus 0.002% or whatever. But you can also be required to give a blood sample. And a blood sample has to be taken under medically acceptable conditions. It cannot simply be done by a police officer. It has to be done by a qualified phlebotomist. And it is immediately sent to the laboratory where it usually is tested by machine. There are machines dedicated to determining blood alcohol concentration. So the whole issue of what a police officer is allowed to do with you if they think that you're inebriated is has been of some controversy, because you realize this begins to get perilously close to illegal search and seizure or investigation without cause, because the officers are stopping just people driving. They don't have to be necessarily be showing something wrong. That anybody can be stopped, and that is because all states have what is called a per se law. So any individual with a defined alcohol concentration, 0.08, is deemed to be intoxicated, no matter what they feel, no matter what they say. You will hear people foolishly say, I can drive when I've had 4 beers, whatever. Whatever people feel about their ability, at this concentration, they are impaired, and it is judged to be that they are sufficiently impaired here to be a danger on the road. However, there is a problem with this, and that is that you can actually be severely impaired even well below this. And unfortunately, an officer then, unless they observe that you are driving erratically or whatever, in which case you can be taken off the road for other reasons as well, people can be permitted to drive off. And severe impairment does occur even well below 0.08. At 0.08, you're about 4 times more likely to be involved in an accident. And at 0.15, which many people reach on a heavy night's drinking and then get in their cars, your chances of an accident rise to about 25 times normal. The take-home lesson is, as far as driving is concerned, is there's no safe alcohol level. It should be 0. You can you'll be severely impaired below the legal limit, and you can still be out on the roads and driving when you are suffering profound deficits because of alcohol in your blood system. So the safe limit for driving is 0. And there are many countries in the world where they effectively pursue that policy. This is just a graph of it shows exactly the same. 25 times at 0.15%, 4 times at 0.08. And just realize you've got 4 times the chance of having an accident. That's high already, let alone 25 times. If you are from New York, you may remember this particular case here. There is a short news clip here for you to watch, but you can chase this down. I think it's on Netflix. There is this movie, There's Something Wrong with Aunt Diane. It's one of New York's most notorious drunk driving cases, which happened a couple of years ago. Okay, so this issue of officers being able to subject you to breathalyzer and to field sobriety tests, even in what would seem to be without cause, is because all states have adopted what is referred to as an implied consent. And that is that if you get into a motor vehicle and drive it, you automatically give consent to any officer to test you for alcohol intoxication. And if you refuse, you will immediately lose your license. And you will, even if you were not intoxicated, you will lose your license for refusal and for period determined by the courts. There's a specific reason for this, and that is that people who are impaired with alcohol frequently become belligerent and contrary, and they will attempt to refuse to be tested. And this is a way of removing them immediately, because they have immediately broken the law, whether they are drunk or not. If you refuse to be tested, you've broken the law and you are removed from the road. And this not only means that people are aware and get in a car, I'm telling a police officer they can test me, but it also gets possible drunk drivers off the road as quickly as possible. Okay, so just for the rest of drugs, I'm only going to just briefly go over. I'm not going to go into any great detail, but I want to realize the forensic toxicologists, as we did for alcohol, what they are going to do is going to look for the drugs in circulation in the body. They're going to try and identify them and then determine the concentration and provide an assessment, especially in court, of the likelihood of impairment by the presence of those drugs, or in the case of a murder or homicide or whatever, they will testify in court to the impact of the poison, whatever, on the human body and why it results in death, and whether they found it in sufficient concentration. So there's some huge difficulties that face a toxicologist. The first is, as I've told you, there are thousands upon thousands of substances which they could possibly identify, and they may have no clue about what those are, and it requires them to screen for an enormous range of drugs in an attempt to identify and then determine a concentration. The second big problem for a toxicologist is that the concentration of the drug in the body may be very, very low. It may still have a very profound effect, physiological effect, but its actual concentration may be very, very low and very difficult to measure. Thirdly, the body metabolizes drugs. It metabolizes them very rapidly. In some cases, toxicologists can look for the presence of metabolites and back calculate to what the original concentration of the original substance was. Lastly, the toxicologist is then called on to make a determination of what the impact of that concentration on the functioning of that person was. And typically the toxicologist will work with blood, and in the case of autopsy, with body parts, with samples from the liver, the kidneys, etc., brain, etc., etc. You will have heard, of course, about the use of urine and of urine testing. Urine testing is very widely used to test for previous drug usage, but it's not a very good way of measuring, of trying to back calculate and work out how much or when a person actually ingested the drug. It is very often simply an indication that at some point in the relatively recent past, somebody has actually ingested a drug. So urine testing is commonly used where workplace testing is authorized and that sort of thing. It's not a very useful forensic technique. I will just tell you that this issue of trying to identify from all the thousands and thousands of different drugs could have been used. There are two very sophisticated analytical techniques which toxicologists make use of in particular. And I'm just going to tell you the names of them. I'm not going to discuss how they work. The one is called mass spectrometry, and the other is called gas chromatography. And both of them look at the actual molecular structure of substances in an attempt to identify them and then to determine a concentration. They are very, very sophisticated techniques. If you're interested, you can go and read the section in your book, but just remember those two names, mass spectrometry and gas chromatography. They can be used individually, but they are often linked together in a single analytical technique. And again, it looks at the actual molecular structure of substances to try and identify them. My last thing that we do need to talk about in analysis is actually the use of hair. Now, hair is a very useful substance because if you're lucky enough to have any, your hair grows at about a centimeter per month. It varies from person to person, but it's about a centimeter per month. And it grows constantly. Your hair, an individual hair, actually has a lifespan of months to years. And so it's continually growing. A hair is actually manufactured by a hair follicle. Initially, it's living cells, and the cells die and get packed together. They kind of get tiled together to form the hair shaft. It's a continual process. But those living cells in the hair follicle, if you are using drugs, they actually pick up drugs and they embed them into the dead cells that form the hair shaft. So the hair shaft begins to form a continuous record of drug usage. And this can be extremely useful. We can pick up all sorts of things from hair, not only drug usage, for instance, illicit drugs like cocaine or whatever. You can measure cocaine usage over a period of months by looking at the hair shaft. But you can also, in cases of homicide, for example, where people have been poisoned, excuse me, you can pick up the presence of the poison in the hair shaft and work out when they were dosed with the poison. And so this is what, in the old days, they would take hair and they would cut it up into small sections and analyze each little individual section, dissolve the hair and analyze it, et cetera, et cetera. But nowadays, there are machines which will do this, and they will take a whole lock of hair and they will screen through the hair. Obviously, close to the scalp is going to be recent. Further away is going to be more distant in time. And by machine can actually analyze for the presence of the drug. And it provides a very accurate, very detailed timeline for ingestion of drugs. The very last thing that I'm going to talk about, we have talked largely about drugs as poisons, but of course there are many poisons which are not drugs. Hair analysis, for example, is often used for where people have been poisoned with something like heavy metal, arsenic, antimony, mercury. It's a hair analysis, by the way, is a very useful way of measuring environmental exposure, for example, to mercury or to lead. These are all used and still used as murder weapons. And often somebody committing homicide will administer the poison over a length of time. One dose seldom enough, and many of these things are cumulative in the body. So they can administer over a long period of time, but that will be picked up very easily on a hair analysis. There's one poison which is very, very common and is commonly associated with accidental poisoning and with suicide. And this is carbon monoxide. Now, carbon monoxide, that's its chemical formula, CO, and it's the byproduct of inefficient burning of a fuel, either charcoal or a fossil fuel like petrol or whatever. People, for example, are commonly poisoned by carbon monoxide by using a generator, an electricity generator inside a closed room. This is very common. But people are also poisoned by using
inefficient heaters, various other things. Carbon monoxide poisoning is very, very common. And what carbon monoxide does is it binds to hemoglobin in the blood. Now, normally, hemoglobin in the blood picks up oxygen in the lungs, transports it around your body, and releases it where the oxygen concentrations are low. So the hemoglobin has to be able to pick up oxygen and release it, pick up oxygen and release it. Carbon monoxide binds to the hemoglobin irreversibly, and it will not allow oxygen to bind. So you effectively suffocate, you're starved of oxygen, but unfortunately, your body does not register the presence of carbon monoxide. And this carbon monoxide commonly produces a symptom of sleepiness. So people fall asleep and carry on breathing the carbon monoxide and effectively suffocate. It's often at autopsy very easy to recognize, because when hemoglobin binds carbon monoxide, it turns a bright pink color, and the whole body turns this pink, cherry pink color. So there, again, it's measured using a spectrophotometry of some sort in the laboratory, but the blood can also be tested. I just mention it because it is so commonly results in accidental death, but it's also commonly used as a method of suicide, because a car engine, for example, burning fossil fuel, will produce substantial amounts of carbon monoxide. And so that, unfortunately, is a common method of suicide. And I think that's it for today. Okay, so do any of you have any questions? If not, I'll bid you goodbye. And of course, this is recorded and posted, and then tomorrow's class is recorded as well. Okay, so I shall see you then.